This is cover test, measurement errors for V551 ocular motility and refraction. How the prism is held in front of the eye can change the amount of the prism the patient is actually seeing through. This is based upon geometric optics. The final prism diopter deviation is the sum of the deviations at each surface. This is dependent upon the angle of incidence or how the light hits the front surface of the prism. How the prism is held in front of the eye affects these angles, different for each prism power up to 20%. There are three main prism measurement positions. There's Prentice's position, where the prism is angled slightly off from the face, from the eyes. There's the minimum deviation position, where it's angled in the opposite direction. And then there's the frontal plane position, where the back surface is front to the eye. Most clinicians use the frontal position to measure the deviations, where the back surface is flat against the eye. However, it's important to keep this in mind. Glass prisms are calibrated for use in Prentice's position, and most plastic prisms, like the ones we have in our clinic, are calibrated for the use in the minimum deviation position. This error varies given the position of the prism, which it's held, and its power. For most phoreas, these errors are relatively small, 10% or less. A 10 prism diopter would measure actually 8.89 based upon these deviations in the prisms and the angles. However, for larger prisms, it's much more significant. A 40 prism diopter glass prism held in the front of the position of the strabismic eye would only actually measure 32 prism diopters, or 20%. Here's an example of what would happen with a 40 prism diopter lens as you vary its angle from which it's held. We are typically, like we said, measuring the Prentice's, which would be actually 30 prism diopters off. We have exactly what we measured, and that's what it was calibrated to. As we increase the angle of the prism, the amount of prism changes significantly in this example. Thank you. The end.